In this video, we will learn about all the essential networking devices used to create and set up a computer network, how they work together to enable data communication, how devices on a network communicate with each other, and how they access the internet. We will cover what a hub, switch, router, modem, repeater, and wireless access point are and how they work. These devices are covered in a logical order. If you want to jump to a specific device or devices, you can use the timestamps. So let's start with the hub. To understand a hub, let's first discuss why hubs and similar devices are needed. This will provide the necessary context for understanding hubs and switches. Suppose device A wants to send data to B. To send data, we first need to connect these two computers directly with a wire, the Ethernet cable to be specific. Once you connect A to B, both computers are now connected to each other and it technically is a network. Now both connected devices can send data to each other. Obviously it is the simplest possible network. This method of connecting computers works well for two devices. However, if we add a third computer, we then need to connect it to both of the other computers for them to communicate with each other. As we add more computers, we must connect each new computer to all the existing computers. This direct method of connecting devices to each other becomes increasingly difficult and impractical as the number of computers increases. It is simply not scalable or efficient. Now this is what a hub solves. Hubs were developed to simplify network connectivity and communication. A hub simplifies the process of connecting devices to a network. A hub is a central multi-port device. It has several ports or LAN ports like these, where devices connect through Ethernet cables. To connect your computer to the hub, you will need an Ethernet cable. Connect one end of the Ethernet cable to your system's LAN port and connect the other end of the Ethernet cable to the hub or hub's LAN port. Similarly, other devices can connect to the hub through an Ethernet cable. Once you connect your system to a hub, now you can communicate with all the devices that are connected to the hub. These connected devices can send data to each other through the hub. Now, these connected devices have created a network. This is called a LAN or local area network. If you remember, a LAN basically refers to a network that covers a single geographic area. This fits into the LAN category because all these devices are connected locally in the same room. A simple LAN can be created using a switch or hub by connecting devices to them. Now let's understand how a hub works and facilitates communication between devices. The way a hub works is that when it receives a packet, it sends that packet to all the devices connected to it. Let's say that A wants to send data to C. The packet first goes to the hub and the hub broadcasts or sends the packet to all devices connected to it, including the destination device C. The hub basically copies the packet to all its ports. However, by default, all other devices reject or discard the packet except for the intended device C. Only the destination device C accepts the packet. Each packet contains the MAC addresses of the sender and receiver. When the packet arrives at device C, it checks the destination MAC address in the packet to see if it matches its own MAC address. If the MAC addresses match, then device C accepts the packet because it is intended for it. So that's how a hub works. Each packet that arrives at the hub is sent to all the connected devices. However, only the device for which the packet is intended accepts it, while others reject it. Similarly, all other devices connected to the hub can send data to any device that is connected to it. The communication flow remains the same. The packet that one system sends to a specific system connected to the hub is sent to all other devices connected to it. This is a drawback of a hub. We will discuss it in the next video. So guys, that's how a hub simplifies connectivity. You only need an Ethernet cable to connect to the network or hub, and then you can communicate with all other devices connected to it without having to connect to them directly. The switch is essentially an improved or upgraded version of a hub. It was developed to eliminate the drawbacks of hubs. A hub has two very obvious flaws. It is not an intelligent device because when it receives a packet, it forwards the packet to all the devices that are connected to it, even if the packet is not intended for those devices. The packet is still forwarded to them. This creates a security concern because by default devices connected to a hub only accept or receive the packets that are sent to them. However, a computer or network card can be configured or modified to accept packets that are not sent to it. Now, this modification makes the network less secure because devices can potentially receive and process data that is not sent to them, and they could potentially intercept and steal sensitive data being exchanged between other devices. Another drawback of a hub is that it generates unnecessary network traffic because instead of sending packets directly to the intended receiver, a hub sends all packets to all connected devices. This can lead to bandwidth congestion and slow down the network for all users. Now, the switch basically addresses these two problems or limitations of a hub. The switch is similar to a hub. This is how a switch looks like. A switch is also a multi-port central device with many LAN ports. The total number of ports in a switch depends on the size and type of switch. Most switches have a minimum of 5 LAN ports, and there are switches with 12, 24 and 48 ports as well. The switch allows computers or other devices to connect to a network through an Ethernet cable, so that they can communicate with each other and access the internet and network resources. The process of connecting a device to a switch is the same as we discussed in the previous video. We have to connect one end of the Ethernet cable to the computer and other end of the Ethernet cable to the switch. We can connect computers, servers or printers to a switch using an Ethernet cable, which allows them to communicate with each other. Once you connect devices to a switch, it creates a LAN or local area network. A simple LAN can be created using a switch by connecting devices to it. Unlike a hub, a switch is a smart device. The way a switch works is that it stores the MAC address of each device connected to it. A switch basically learns which device is connected to which port by maintaining a MAC address table. The MAC address table stores the MAC address of each device connected to the switch and the port number on which the device is connected. For example, if device A connects to port 1 on the switch stores its MAC address in its MAC address table along with the port number to which it is connected. This is how the entry looks like in the table. This means that computer A is connected to port number 1. The switch does this for every device that connects to it. It stores the MAC address of each device and the port number to which they are connected. And how a switch exactly acquires the MAC addresses will be covered in a separate video. Now let's see how a switch works and forwards data. Let's say device A wants to send data to C. The packet first goes to the switch. Every packet contains two MAC addresses, the MAC address of the sender and the MAC address of the receiver or destination where the packet needs to be delivered. Now the switch checks the destination MAC address in the packet and matches it against the addresses in the MAC address table. If the destination MAC address is found in the table, then the switch forwards the packet to the port number associated with that MAC address. In this case, the destination MAC address is at port number 3, so the switch forwards the packet to the device C. So unlike a hub, it sends packets only to the intended device. Similarly, if any device connected to the switch wants to communicate with another device, the same process is followed. The packet goes to the switch checks the MAC address table and forwards the packet to the destination. A switch is capable of reading MAC addresses, whereas the hub can't read MAC addresses. That's why it forwards packets to everyone. So guys, that's how a switch works. The data is delivered or forwarded only to the intended device, making it secure. A switch is among the most commonly used devices today. In wired network, a switch is always the preferred device. To understand routers, let's first review central devices we have already covered, such as hubs and switches. This will help us understand routers more clearly. A hub or switch allows devices to communicate with each other within the same network or local area network, right? The devices connected to a switch can communicate with each other easily. Now let's say that device A wants to access Google or the internet. However, Google server is not available within the network or LAN. It is located somewhere on the internet. Therefore, to access google.com or the internet, computer A and all other devices in the network must leave their own network to reach or access Google. A switch can't route or send data outside of the network. It is designed to facilitate communication only within the same network or LAN. So we need a device that can route or send data packets outside of the local area network. That device is a router. A router allows devices on LAN networks to communicate with external networks such as the internet. This is how a router looks like. So to access the internet, we must connect the switch to a router and the Ethernet cable is used for this connection. Just connect one end of the Ethernet cable to any LAN port of the switch and other end of the cable to the LAN port on the router. A router has at least one LAN port. Once the switch is connected to the router will connect your network to the internet. Now, devices connected to the switch or network can access the internet. Now, when any device on the LAN network needs to access anything on the internet, the switch forwards packets to the router and the router sends the packets to the destination. A switch understands MAC addresses, which means it forwards packets based on the destination MAC address. On the other hand, a router understands IP addresses. A router forwards packets based on the destination IP address in the packet. Now let's understand the complete communication flow with an example. Let's say device A wants to access Google. The packet first goes to the switch and then the switch forwards the packet to the router. As mentioned earlier, routers work with IP addresses. The router checks the destination IP address in the packet. In my case, the packet contains IP address of Google, and based on this destination IP address, the router forwards the packet to the Google, and the reply that Google sends back to device A will follow the reverse path like this. Packet arrives at the router, which forwards it to the switch, and the switch forwards it to the destination device A. Similarly, if any other device connected to the switch or wirelessly wants to access the internet, communication process remains the same. Remember that most routers also have a built-in switch. You can directly connect computers to a router using an Ethernet cable. However, a router typically doesn't have many LAN ports, so a dedicated switch is typically used for wired connectivity and provides connections to more devices. So if you are directly connecting to the router, it means the router has a built-in switch. Another very important function of a router is to select the path that packets need to take to reach their destination and then forward them. The internet is essentially a huge collection of interconnected networks or LAN networks. This means that different networks communicate with each other to forward data to the correct destination. The networks communicate with each other through routers. Routers connect the networks. Therefore, each network must have a router if it wants to access the internet. Since the internet is a web of interconnected routers, data must go through these routers to reach its destination. The job of a router is to select the best available path that packets need to go through to reach their destination. This is called routing. Routing is the process of selecting the path that data must go through to reach its destination. There are two main types of routers: wireless routers and wired routers. A wireless router allows devices to connect to a network wirelessly using Wi-Fi. A wireless router is used to create a WLAN, wireless local area network. On the other hand, a wired router allows devices to connect to the router using a wire or an Ethernet cable. These routers are mostly used in home networks and small offices. Keep in mind that a wireless router typically supports both wired and wireless connectivity. A wireless router may or may not have multiple LAN ports. However, each wireless router has at least one LAN port. A repeater is a simple networking device which is used to regenerate signals. Basically, it extends the range or coverage of a network. It is also known as an extender because it extends the network's range. What happens is that the signals, whether wireless or wired, weaken as the distance increases. The longer the signals travel, the weaker they become. This weak signal can cause issues such as a slower internet connection and frequent disconnections. So, to boost or enhance the signals, we need to use a repeater. let's understand repeaters with an example. Let's say you have a Wi-Fi network at home and the wireless router is installed on the ground floor and you are staying on the second floor. Now, if you are close to your Wi-Fi router, the signal remains strong and you can access Wi-Fi without any problems at maximum speed. However, as you move further away, the signal or radio waves weakens. Walls and other obstacles can further weaken the signal. As a result, someone staying on the second floor may not be able to use Wi-Fi consistently. They may experience frequent disconnections and a slow connection. This is where the repeater comes in to solve the issue. A repeater takes the weak Wi-Fi signals and amplifies or regenerates them. A repeater is placed where the signals start getting weaker. Now the repeater takes the weak signals and regenerate them like this. The sole purpose of a repeater is to regenerate signals, making them stronger and more accessible to those who are far away from the wireless router. Now everyone can get good signals and access the internet. Now the same principle applies to an Ethernet cable or connection. A repeater can also be used to regenerate wired signals. What happens is that typically after 100 meters, signals in wires begin to weaken. This phenomena is called attenuation. In such cases, a repeater can be used to regenerate or boost signals so they can reach the destination. So that's all you need to know about repeaters. Thank you very much, guys. A wireless access point is another important device used in computer networking. A wireless access point is also known as a wireless AP. This is what a wireless access point typically looks like. It usually has external antennas. However, some access points have built-in antennas as well. Before we discuss the wireless access point in detail, let's talk about routers briefly. There are two types of routers, wireless routers and wired routers. A wireless router supports wireless connections, allowing different devices to connect to the network wirelessly using Wi-Fi. On the other hand, the wired router does not support wireless connectivity. You can't connect to a wired network or router using Wi-Fi. We have to use the Ethernet cable to connect to a wired router. Now let's say that you have a wired router that does not support wireless connectivity and you want to enable wireless connectivity so that devices can connect to the network wirelessly using Wi-Fi. This is where the wireless access point comes in to solve the issue. A wireless access point is a network device that allows devices to connect to a network using Wi-Fi or wirelessly. Now, to enable wireless connectivity, we need an Ethernet cable. Simply connect one end of an Ethernet cable to the wireless access point and the other end to the wired router. The wireless access point can also be connected to a switch as well. Now it will start transmitting the radio waves. Now devices such as computers, mobile phones or tablets can connect to the network wirelessly using Wi-Fi. So an access point is a device that allows wireless devices to connect to a wired network. A wireless access point can also be used to extend the range of a wireless network. Wireless access points are frequently used in homes, businesses, and other public places to extend the reach of a Wi-Fi network and offer improved coverage. Let's say if you have a large office with multiple blocks and many people, a wireless router has limited range and it can't provide connectivity to everyone in the large block. This is where we can use the wireless access point. You can add one or more wireless access points to extend the Wi-Fi signal to all areas of your office or home. To do this, you simply need to connect the wireless access point to the main router using an Ethernet cable. Once the access point is connected to the main router, it will provide access to the wireless network. Now, devices from all corners can access the network using their Wi-Fi. All the devices are connected to a single network using different access points. This entire network is managed by the main router. If any device on the network wants to access the internet, the packets have to go through the main router. Everything is managed by a single router. Wireless access points are well suited for such setups or large offices because they are easy to manage. Alternatively, you can also use wireless routers instead of wireless access points to provide wireless connectivity to everyone by placing individual wireless routers instead of wireless access points. However, this can create manageability problems. For example, if you use wireless routers instead of wireless access points, you will need to configure each router individually if you want to make changes to the network. However, with wireless access points, you can manage the entire network using a single router. This is because wireless access points are typically connected to a central router, which allows you to configure all the APs from a single location or device. Now let's talk about difference between a wireless router and wireless access point. Wireless routers and wireless access points are two different devices with distinct capabilities. A wireless router can support both wired and wireless connections. Typically, a router has multiple features such as a built-in switch, firewall, DHCP server, etc. A router supports all these features. On the other hand, the sole purpose of a wireless access point is to provide wireless connectivity and extend the network coverage. It only transmits radio waves so that devices can connect to the network wirelessly. That's all you need to know about the wireless access point.